All right, so today we're going to start on page 413 if you're following along in your packets, which is 30-1, but it's just day 2. So we're going to start at example 4. It talks about that what it means to be linear. Linear means that there is a constant rate of change, so that it's going up 2 over 4, up 2 over 4, up 2 over 4 every single time. Constant just means staying the same. And we know that when we plot linear data that it makes a straight line. So most of the data we're going to look at over the course of the rest of this unit will end up falling in a straight line. So it says Jamila is using a straw to drink water from a cylindrical cup. The height of the water remaining in the cup is a function of time that the person has been drinking. So if you're drinking out of the water, you're expecting or out of the cup, you're expecting that water level to go down. It says the following gives the height of water at different time intervals. So you were supposed to have this graph filled out already on your in your packet if you're following along in your packet. So taking a look at the graph on the right, we've got to fill out the table on the left in terms of it asks us what the height of the water is given a particular time. So if we first look at that first point up here, 0. When the time is 0, the height is 15 centimeters. If we look at the next one at 10 seconds, that height is 12.5. I know that's a little bit harder to see, but it's right in the middle of 12 and 13. And then at 20 seconds, it's up here at 10. And then at 30 seconds, it's at 7.5. At 40 seconds, it's at 5. And then at 50 seconds, it's in between 2 and 3, so it's at 2.5. Okay, so again, filling out the table based off of the graph just depends where those points actually fall. All right, so the next question says, describe any patterns that you observe in the table about the height of the water over time. So let's go back to the graph or to the table. So one of the things that I've actually already mentioned is that the water level is going down, right? So as those numbers are decreasing as the time goes on. And again, that makes sense if you're drinking from a cup, the amount of water liquid in the cup is going down. More specifically, we can see that it's going down 2.5. So I'm going to say negative 2.5. From 12.5 to 10, it's going down another negative 2.5. From 10 to 7.5, it's another negative 2.5. So all of those are going down 2.5. And if you look at the time's going up by 10 seconds. So if we wanted to describe a pattern of the water over time, we could say that the water decreases, okay, because that water level is going down. And we could be more specific. We could say it decreases 2.5 centimeters every 10 seconds. Okay, and then it says, is the relationship between the height and the time of the water linear? And they want us to explain using the graph and then also using the table. So we can look at the graph. And again, to look at the graph, we just need to look at what's happening with those points. And we know it goes down 2.5, and then it goes over 10 seconds. It goes down 2.5 over 10, down 2.5 over 10, and that pattern keeps going on down 2.5 over 10. So we would say, is it linear? Yes. Okay, we could say the graph forms a straight line. And it goes, we could say down 2.5 centimeters and right 10 seconds. Okay, using the table, which we already talked about a few seconds ago, if you take a look at it, these are all going down 2.5. These are all going up 10. So we could say yes, because it has, and one of the words we use a lot, we can say a constant rate of change. Okay, so the rate of change, remember, is that change in y over the change in x. And again, that should be on your word wall from when we were still back in school. All right, so taking a look at the next one, it says, what is the change in the water level for 20 to 30 seconds? Okay, so if we look specifically, so I'm going to go ahead and erase what I have here. if we look specifically from 20 to 30 seconds, what's happening? And we could say the water level goes down what? That water level goes down 2.5 centimeters. Okay, so what is the change in the water level? We could say the water goes down 2.5 centimeters. And again, the rate of change, we've actually been talking about this already. So it's the change in y over the change in x. And it went down 2.5 centimeters and then over 10 seconds. If we plug that into our calculator, that's negative 0.25. And we would say centimeters per second. So the water level change is down 0.25 centimeters each second, or you could have left it as it was here and you could have said down 2.5 every 10 seconds. All right, we are going to skip number 9 and move on to number 10. Number 10 asks us to write a function or write an equation that gives the height of the water in terms of time. So we know that the height of the water was our y value based off of the table, and they want us to use the letter h for y, and then it says the time, which was our x value, they want us to use the letter t. So normally when we write our equation, it's y equals the rate of change times x plus our initial value, or our y-intercept is that starting point. Okay, but instead of using the letter y, they want us to use the letter h. So we're just going to say h equals, okay, we just talked about our rate of change a few seconds ago back in number 8. It's negative 0.25, so negative 0.25. And instead of using x, they want us to use the letter t. And then our initial value, so if we go back to either the table or the graph, here we see that our initial value, our starting point, that y-intercept is 15, and we can see it from the graph too up at the top. Sorry about scrolling back and forth, but then we're going to add 15. All right, so number 11 says, how long will it take for Jamila to drink her water, or to drink all of her water and completely empty her cup? So we're going to do this a couple different ways because it says use multiple representations. And the first way would make sense is since we just wrote that equation, let's use the equation. Okay, h stands for the height of the water. And we know that if she drinks all of her water, there's no water left. So that height would be 0. And then we get negative 0.25 t plus 15. And then all we have to do is solve that equation. So we got to move the 15 over to the other side by subtraction. So we get negative 15 equals negative 0.25 t. And then since it's multiplication here, we've got to do the opposite and divide. So divide by negative 0.25. And we end up getting t is equal to 60. And the time was in seconds. So we'll go one step further and say 60 seconds. Okay, so that's one way to do it with the equation, which in my opinion is probably the easiest way. If we go back to the table, and again, I'm going to clear out some of that so that we can see it. We could use the table too. We could just continue, and I know we've done this before. If I were to keep going at 60, remember these are all going down 2.5 and these were all going up 10. If this goes up one more to 60, and if I subtract another 2.5, that gets me down to 0. So I could look at it from the table also. Or I could even use the graph and I could go down 2.5 and over 10 seconds again, and that would get me at 60 seconds. So there's a bunch of different ways that you can figure that out. It obviously happened to work nice on this one. If it wasn't going to be a nice value, say it was, 60.4 seconds, we wouldn't be able to tell that by the table or the graph. That equation is probably the best way to go. All right, the last example we're going to look at is talking about a farmer and his cylindrical silos filled with grain. It says the amount of grain in the silo is a function of time. All right, so our x value is going to be time and our y value is going to be bushels. And that's just a measurement of how much grain there is. Up at the top it says a bushel is a unit of dry volume. It's approximately 8 gallons. And a silo is just that storage that storage unit or the place that they use to hold the grain that I'm sure you've seen on the side of the highway by a farm driving somewhere. All right, so it gives us the values, and the first value says, or the first question says, complete the graph. So all we have to do is put those points on the graph. I had already put in the 500, the 1,000, etc. on there. So between 0 and 1,000 would be 500 right in the middle. So I've got 0, 0. I'm going to zoom in a little bit. I've got 20, 500, 40, 1,000, 60, 1,500, 80, 2,000, 100, 2,500, 120, 3,000, 140, 3,500, and then the last one is 164,000. So again, that looks like it's a pretty straight line. But again, number 14 is going to ask us to figure that out. So number 13 says, what's the rate of change? Okay, so remember, rate of change is the change in y over the change in x. I would say it's probably easier to look at the table to figure that out. Our y values, those are all going up 500 all the way down. So it's 500, and it's a positive 500 because it's going up. And our time, if we look at all those times, those are going up by 20, so that's a positive 20. And if we take 500 and divide by 20 in our calculators, that just gives us 25. So our rate of change is just 25. Number 14 says, is it linear? Okay, so if we look at, remember to determine if something's linear, it has to make a straight line. So it looks like our graph makes a straight line. And then the other thing is it has to have a constant rate of change. Oops, constant rate of change. Okay, so yes, it's linear because it has a constant rate of change. All of the y values or the bushels were going up 500 and all of the times were going up 20, which is what we just found out in number 13. Number 15 says, okay, go ahead and write an equation or a function for this situation. They want us to use t for time, and they want us to use the letter b for how many bushels. So instead of using x and y, we're going to use t for time, and we're going to use b for bushels. All right, so for number 15, it's going to be y equals, or in this case, b equals. Remember, it's rate of change, which we found was 25, so it's going to be 25 times x, but we can't use x, we're going to use t, so 25 times t, or just 25t, and then it's plus the starting amount, and if we look back at the table, we'll see that that starting amount was 0, or if we look back on the graph, we can see that starting amount is 0. So we could either write equals 0 or plus 0, or we could just go ahead and say b equals 25t. All right, and then the last question says, okay, if the silo holds 7,000 bushels, how many hours will it take to fill? So that would obviously be something important if you had a farm. So again, we're going to use this same equation right here, b equals 25t. We know we have 7,000 bushels, so we're going to plug that in for b. So it's 7,000 equals 25t. This equation is a little bit easier to solve than the last one. All we have to do is divide by 25. And when we type into our calculator 7,000 divided by 25, we get 280, okay? And again, it asks us how many hours, but here's a problem because time up here was in minutes. So I know that it's 280 minutes. So all we would have to do is we would have to take that 280 and divide by 60. So if we talked about hours, so 60 minutes is 1 hour, 120 minutes would be 2 hours, 3 hours would be 180, 4 would be 240. So we know it's 4 hours, and then to go from 240 to 280, 4 hours and 40 minutes. Okay, we also could take that 280 and we could divide by 60 and get it as a decimal. But in my opinion, 4 hours and 40 minutes makes a little bit more sense because you can figure out that time on a clock. All right, so your homework tonight is a worksheet, which I posted on Schoology. Don't forget that you can go back and you can look at any old assignments and complete those if you're missing them. If you haven't taken the quiz from last week, you need to email me and arrange a time to take that. I have now closed that quiz because we need to have a conversation because those of you that haven't taken the quiz haven't been doing a lot of work either. So send me an email and we'll figure out a time for you to make up that assessment. Hope you guys have a great week. Thanks.